All right, so on question number 1, we're just trying to see if the ordered pair that we came up with is actually the right solution. That's what we're going for. So if we have an ordered pair, the first number listed is going to be our x. The second number listed is our y. In order for this to be our solution, in order for it to be the right answer, if you will, I need to check, I need to substitute. I'm going to pull the first equation off to the side. In for the x, wherever I see an x, I'm going to put a 1. Wherever I see a y, I'm going to put a -2. So any place I see an x, I'm going to put a 1. Any place I see a y, I'm going to put a -2. This piece right here, this left-hand side, you could put that right in a calculator if you wanted to. Or you can do the computation piece by piece. 2 plus -2. So 2 plus -2, I get a 0. 0 equals 0. That one checks. Checking in 1, though, is not good enough. I need to make sure that that ordered pair makes both equations true. So into the second equation, and I'm just pulling these apart. That's something we've talked about quite a bit in here. Pull them apart, write them separately, write them side by side. The negative sign is going to stay, and then in place of x, I'm going to put a 1. In place of y, -2. 2 times -2 is -4. -1 plus -4 is -5. Does -5 equal 5? No. So this doesn't check. This is not my solution. So that's how I would know if I'm taking my test or I'm doing some of the practice worksheets, whatever the case may be. If I get a solution and I substitute it back in and I check it, it has to work in both equations. If it doesn't, I need to go back and see if I can find my mistake. Maybe I made a number negative that should have been positive. Maybe I added and should have subtracted something. Whatever the case may be. So if you're still unsure how to check, when we get work time today, make sure you're asking me. Use your work time productively. Make sure you're asking me if you're unsure still. Okay? The main focus of today I want to be on the graphing. In question number 2, my first equation I have as y equals. I think almost every one of you out there, before we even started this course, if I asked you what slope-intercept form was, I think you would have been able to tell me y equals mx plus b. You guys probably did that so much last year, you probably got tired of hearing it. So if you can tell me slope-intercept form is y equals mx plus b, then whenever y is by itself and you need to graph, that's your y equals mx plus b. Pick out your slope, pick out your y-intercept. Which one of those things is going to be my slope, the 1/2 or the 3? The 1/2 is my slope. And I'm going to label it as slope, not m, I'm going to label it as slope. How can I move for a slope of 1/2? Up 1, right 2. Sounds good. So then if 1/2's my slope, what's this plus 3 got going on? My y-intercept, yep, it's on the y-axis. Y-intercept, y-axis. Y-intercept has to go on the y-axis. So on the y-axis, I'm going to go up 3. 1, 2, 3. And I'm going to follow my directions for my slope. You guys told me for a slope of 1/2, I should go up 1, and then I should go right 2. We've done a lot of graphing in here this unit, and we talked about needing to find the intersection point. So we also talked about when we draw that first line, let's get as many points as we can. Let's make it as long as possible so we make sure that that first line is perfect. As perfect as we can get it, I should say. So instead of going up and right, how else can I move and still stay on this line? Down and left. So down 1, left 2. down 1, left 2. And I have my first line. I have my first line. I really think it helps. I know for some of you, you don't want to put in the extra work to rewrite these off to the side and label things like I did. The very least, have them on this sheet so when you go to do some of the practice, you have things nicely labeled on your example. So take a minute here. Try graphing that second one before I do it up here. If you think you had a solution, go ahead and check it. I'm just going to work my way through it up here. Go ahead and check it. If you think you got a solution, check it and see. You don't have to wait for me to graph it up here. Get in that habit of checking. Even if you're just putting things in the calculator to check. Even if you're just putting things in the calculator to check. Our slope for this one is negative 3 over 2. So now the negative sign, though, guys, you kind of choose which one it goes with. But remember, only one direction can be negative. So if you tell me that this could be down 3, that means I have to go right 2. Down is negative, right's positive. If you have a negative slope, only one direction can be negative. If you have a negative over a negative, if I go down and then I go left, negative over negative turns positive. We could also go up 3 and left 2. Negative 5 is my y-intercept. Y-intercept goes on the y-axis. My down 3, right 2, that's not doing much good. Not at all. So I've got to go up 3 and right 2. Up 3, right 2. Now some of you might be thinking, Miss Galley, I swear I did that on my test, but then I think my graph's right, but then you still marked one wrong. If this is all you did on your test, yeah, you would lose points. I know you're thinking, but wait, Miss Galley, you graphed those lines. We know they're right. You graphed them. You need the intersection point. You need the intersection point. Negative 4, 1. That's our solution. That's what you would put back in for x and y and see if it works. I'll be more than happy today when you get some time to work to help you check if that's something that you need. Be more than happy to do that for you. So if y is by itself, I know for a lot of you out there, if I tell you use slope-intercept form, you're golden on it. But we've got to be getting to that point, and this is where the practice comes in, of getting used to, I've got to pick that out myself, that's slope-intercept form. So let's check out. So question 2, y is by itself, both equations, slope-intercept form, both equations. So when you're doing some of your practice, have this sheet out. If you're like, oh, I'm not sure how to graph this one. If y is by itself, slope, y-intercept, rock it from there. Question number 3. X and y are on the same side. 4x plus y equals 2. X and y same side. So we do a little xy in our chart. We find our intercepts. For some of you, when I say find intercepts, you're like, wait, Miss Galley, that's the thing with the zeros. Yep, you're right. It is the thing with the zeros. And I like to draw that little t-chart. So I remember to put 0 in for x and 0 in for y. That's what I like to do. Some of you draw the chart, some of you don't. Doesn't matter. Whatever works best for you. Whatever works best for you. So we start off, we're going to put 0 in for x. Your choice, how much work you show on this. Some of you just cover up whatever variable you're putting the 0 in for and you go from there. Some of you like to write it with the 0. Some of you just don't write that term and you write the rest. So you got to kind of find your groove. When we did the graphing unit, all of you in this room could find intercepts. But now that things are mixed together, that's where we get a little unsure. So what we have left, if we have a 0 in for x, all we have left is y equals 2. That's not my solution, guys. That's the y-intercept for the first line. That's the y-intercept for the first line. That's not a solution. This is not substitution. We're putting 0 in for x. We're substituting that in, but this is not the process of substitution. This is the process of finding intercepts to graph in standard form. Next up, 0 in for y. Again, how much work you show is up to you on this. That's just a 0, so I'm left with 4x equals 2. Here's one of the big reasons why I chose this example to graph. Intercepts are not always going to work out perfect. When some of you tried to graph on your test, for some of you graphing was your fallback because that's what you did the most practice on, was graphing. That was the first thing we did. Sometimes the intercepts don't work out very nice. That's why we have other methods. This one is okay, but just know when you find intercepts, if you choose that method, instead of doing maybe substitution or elimination, sometimes when you choose graphing, sometimes you get some decimal or fraction intercepts. That can happen. This one isn't too bad at 1/2. 1/2, though, is not a slope. 1/2 is not a slope. 1/2 is the x-intercept. I go over half of a box. I go over half of a box on the x-axis. It's not a slope, even though it's a fraction. It's not a slope, it's an intercept. Now we talked about with the first line, I want as many points as possible. So I can use those 2 points and I can find my slope. If I start up at the y-intercept of 2, I have to go down 2 and over just half of a box to get to the next point. So I can keep rocking that. Down 2, over half of a box. Down 2, over half of a box. Up 2, left half of a box. So sometimes when you choose standard form, some of you are running into problems on your test, like, Miss Callie, I can't get this graph right. Because graphing probably wasn't the easiest choice. It's just what you knew best. For the second one, x and y, same side. X and y, same side. We've got 2x minus y equals 4. Make sure if you're putting in zeros, x and y should be on the same side. Don't just go with x like, oh, Miss Guy, it's easy to put those zeros and I can go from there. Only if you have standard form. If you have slope-intercept form, putting in the zeros isn't always the easiest choice. It's definitely not. All right, so let's start off with putting a 0 in for our x. So that x term's just gone. Here's another big reason why I chose this example. I'm left with a negative y equals 4. It's not y equals 4. That's what we're going for, is just a plain y, but it's a negative y. So there's really that negative 1 there. So I have to divide by negative 1. My y in this case is really negative 4. We've got to watch out for those negative signs. They have to come with our variable. So y is at negative 4, y-axis, I go negative 4. Put a 0 in for y. Again, if you're just covering things up, that's fine. If you need to actually physically write the 0, do what you need on these. That 0 is just gone. 0 is literally nothing. I always divide by whatever's in front of my variable. And we get x equals 2. So on the x-axis, I go 2. If you're making that little chart and you're putting in zeros, you are finding 2 points. One on the y-axis, one on the x. There's no slope there. You're not finding slope. That is not the process of substitution. I don't just substitute in and then have the answer 1/2 2. That's not substitution. That's just graphing with standard form. To finish this off, you need to make sure you have your ordered pair. You need to make sure you have your ordered